Hi, I'm Matthew, and I'm going to show you how to solve the first problem on the first test. So I struggle with this problem because I simply blanked on how to write VPython, and I lost a lot of points for simple mistakes, but today I know how to solve it. So this problem gives you everything that's written down is given to you, and the program wants to calculate the net electric field from two identical particles, Q1 and Q2, at 10 equally spaced locations in a circle of radius r, centered at the origin of the xy plane. So each of these particles has a charge of q, and our job is to fill in the blanks given in the code. So the code gives us that the charge is 20 times 1.6 e negative 19, or 20 times the charge of a proton. The radius is 2 e negative 10. The constant UFPES 99, and it gives us a scale factor of 1.5 e negative 21. So first, the program draws two spheres for Q1 and Q2. One is at position 0, 4 e negative 11, 0, and has a radius of 1 e negative 11, and the color is blue. Next is Q2, which is at 0, negative 4 e negative 11 with the same radius and same color. So this problem creates a while loop, and it starts at theta being 0, and d theta is 2 pi over 10, because that's how the charges are spaced around the circle. So it initially asks us to create the new vector value for obs location using the angle theta. So this can be written down as obs location equals vector. The x-axis is going to be r times cosine of theta. The y is going to be r times sine of theta. And then the z is simply 0 because nothing was going on in the z-axis. So next, it wants us to calculate the net electric field at the observation location. So in order to do this, we need to define the radius 1, which equals obs location minus q1 dot position. This gives us the position of q1. And then we can calculate the electric field due to that. So E1 equals UFPES times Q over the magnitude of R1 squared, and you write squared with 2 asterisks. And then all this is times R hat, which can be written in VPython as norm of R1. So now we need to do the same thing for the second particle, which is R2 equals obs location minus Q2 dot position. E2 is now UFPES times Q, because Q doesn't change, mag of R2 now squared, and again times R hat, which is norm of R2. So now the total E net is simply E1 plus E2, and that's to fill in the blank that they're asking for. So lastly, this problem asks to create an arrow to display E net at the obs location and to also scale it. So once we do that, we have EA equals arrow, and now we need to define the position. So position equals obs location. That's where we want the tail of the arrow to be, and then the axis is where it points to. So the axis is equal to E net, which we have already, and it wants to be scaled, so we just multiply this by the given scale factor, which was described earlier. And that's everything for this problem. If you want to study more, To make this problem harder, you can think of it if there are different point charges, or if they're not point charges at all, such as a rod or a sphere, a rod or a disc, or anything else that would produce an electric field. And you can also think about if they're not evenly spaced around the circle, how you would do that.